This is Gravity Guy, but most people call him Isaac Newton. One important thing he said is that force equals mass times acceleration. Now what do all these words even mean? Force is a push or pull on something in a certain direction. Mass tells you how much of something there is, and it's also a measure of inertia, but we'll get to that later. And acceleration is the derivative of velocity with respect to time, but that's too many big words for my taste, so let's just say it's how fast your velocity is changing. The key takeaway is that if you apply a force to a fixed mass, you get a predictable amount of acceleration. If you know all the forces acting on a basketball midair, you can predict with 100% certainty if the ball will go in the hoop or your neighbor's windshield. Whoa, did an apple just fall on my head? Yes, Newton, it did. Yeah, that must have happened for a reason, said Newton, as he discovered that two masses attract one another, making the apple fall. Yes, even you, no matter how ugly you think you are, attract pretty much the whole universe at least a little bit. Hey, can you put that on paper? Yup, said Newton, who gave us the law of universal gravitation. In other words, how much do bodies pull on each other given their mass and distance times a constant. Bigger mass, bigger pull. Bigger distance, smaller pull. Actually, a lot smaller pull. You see, as the distance increases, the force gets smaller by the square. That, my friends, is the inverse square law. Gravity is also the reason why planets in our solar system orbit the sun. They got their initial velocity when the solar system formed out of spinning gas, and since there's nothing in space to stop them from moving, they'll keep moving. Hey, that's Newton's first law. The sun is so massive that the force of gravity keeps pulling the planets towards the sun, but the planets are fast enough to essentially fall towards the sun but miss it, and this goes on forever, creating a round orbit.